welcome to the Deep Dive. Today we are tackling something fascinating and, frankly, pretty mission critical. It's this intersection of old school technical SEO and the explosive new world of generative AI.
Right.
And this is a question that, if you are building websites, if you're managing content at scale, or if you're just trying to figure out how to get visibility in the future of search, you absolutely need a technical answer to.
That's fundamentally correct. The listener's challenge here is really all about architecture and capability. They're asking us to get really specific, to pinpoint the technical difference between, say, a traditional indexer like Googlebot.
Which we've known for years.
Exactly, which has been evolving for decades.
Yeah.
And this new class of machine systems, specifically large language models, LLMs, and all the web crawlers that come with them.
And it's not just about complex single-page applications. This hits almost everyone. We're talking about millions of websites that use interactive elements.
Oh, absolutely. Think tabs, accordions, those read more buttons.
Yeah. Dynamic filters, all of it. For years, we've kind of been lulled into this state of, technical confidence because Google got so good.
So good at rendering these really complex JavaScript-heavy pages.
Exactly.
Yeah, the SEO industry, we all worried about it for a long time, right? Can Google crawl JS? And then we just watched as Google poured billions into its rendering service. It basically became this state-of-the-art headless browser.
And developers relaxed. The thinking was, hey, if Google can see it, we're good.
Everyone can see it.
Yeah.
But that's the caution we have to start with. That hard-earned confidence, which was built, entirely on Google's specific infrastructure, it might not, and based on the data we're seeing, it will not just automatically transfer to this new wave of AI crawlers.
So we're facing a pretty sudden, pretty chaotic shift in our basic technical assumptions.
We really are.
So our mission today is to cut right through that noise. We need to get past the hype of LM optimization and get down to the real practical challenge.
Which is making sure your critical content is accessible, not just in theory, but accessible to all machine systems.
That's the key. Traditional search indexes and these new generative AI knowledge bases that are just, eating up user intent.
Right. So before we can even tackle the new players, we have to set the baseline. We have to establish the standard.
And that standard is Googlebot. Specifically, Googlebot's three-stage process.
To really appreciate the architectural difference here, we have to dissect how the most advanced, most resource-intensive crawler in the world, Googlebot, actually works when it hits a page.
Especially a JavaScript-heavy one.
Especially then. And it's a sophisticated, staggered three-stage process. Crawling, rendering, and then indexing.
Okay, let's spend some serious time on this baseline. Because if you don't understand Google's high bar, you can't really appreciate the different bars set by the LLMs.
A different bar is a good way to put it.
So stage one, the initial visit. This is like reconnaissance, right? An eligibility check.
Exactly. Stage one is crawling. It all starts with discovery. Googlebot queues up pages it finds, maybe from internal links, backlinks, or you submit a sitemap.
But it's all about efficiency at this stage.
It is. Before Googlebot even commits to making an HTTP request to download your page, there's a crucial gatekeeper.
And what's it checking for at that gate? What saves it resources?
It checks eligibility right away. It's looking for really explicit, machine-readable restrictions. The clearest one is a disallow command in the site's robots.txt file.
Which is sitting right in the root directory, first thing it checks.
The very first thing. It's a clear signal from you, the server owner, saying, don't spend your resources here.
This is so critical for crawl budget, especially on huge sites.
Yeah.
If that page is restricted.
Googlebot just skips it. It completely forgoes the HTTP request.
Which saves processing power for Google and, importantly, bandwidth and load on your own server.
Right. And if the page is eligible, then Googlebot makes the HTTP GT request. It fetches the raw HTML file, and it moves toward the most resource-intensive phase of all.
Rendering.
Rendering.
This is the heavy machinery. This is where Google has to act like a real browser, and where all the friction with JavaScript really happens.
This is stage two, rendering. So Googlebot gets that initial HTML file. First, it parses it, creating what we call the initial document object model, or DOM.
But there's another check here, right? Another gatekeeper.
There is. Before it decides to execute any JS, it makes sure the page is eligible to be indexed.
So it's looking for that noindex tag.
Primarily a noindex meta tag, right in the head of the document. If it finds that, the process stops. Why waste all those resources on rendering if the content's not going to be in the index anyway?
Okay, so assuming it is eligible for indexing, this is where the resources really start to burn. Why is rendering so much harder than just crawling a file?
Because crawling is just fetching a static file, rendering is. It's like running an entire operating system process for every page.
Wow.
Google has a whole dedicated service for this, the Google Web Rendering Service, or WRS. It's based on a headless version of the Chromium browser, the same engine as Chrome.
So it needs CPU time, memory, network resources.
All of it. It's simulating a real user's browser, has to fetch the HTML, parse it, see the script tags, request all the external JavaScript and CSS files, compile that JavaScript, execute it, and then rebuild the entire page in its memory.
And that complexity, that's the source of the infamous delay, the whole two-wave indexing thing we've talked about for years.
That's the core technical reality. During this whole process, the bot gets two different versions of the content, which defines those two waves. The first is the DOM response.
The first wave.
The first wave. This is the content it understands before any JavaScript is executed. It's the raw HTML, the basic structure, and this is the content that can get indexed really quickly, sometimes within hours.
But the full picture requires patience.
A lot of patience. The second response is the browser render, or the second wave. This is the fully constructed final version of the page. It's what you get only after the rendering service has finished executing all that JavaScript.
So any content that's dynamically injected, comments, product data, links generated by JS, that's only visible here.
Correct. And this can take anywhere from a few seconds to several days. It all depends on Google's resource availability and how complex your site's JavaScript is.
And that time lag, that resource consumption, that's the architectural cost that, as we'll see, LLM systems just don't seem willing to pay.
Exactly. So once that incredibly resource-intensive rendering is done, and Google has the final constructed DOM that looks like what a user sees, then we get to the final destination.
Stage 3, indexing.
Yes, indexing. If the page is eligible and all the information from both the initial DOM and the final rendered version has been parsed and evaluated, it gets stored in the massive Google index.
And then it's ready to be served up in search results.
Right. And the key distinction here is that Google is indexing the final rendered version. That dynamic JS-injected content is treated almost identically to the static stuff as long as the rendering was successful.
That whole comprehensive process. That is the sophisticated baseline that sets the bar so incredibly high.
It really is.
Okay, now let's pivot to a really specific issue within that. Content hidden behind interactive elements. We've established Googlebot is a rendering genius, but it can't click a mouse.
Right. It can't scroll. It can't switch between tabs like a human.
And that limitation is fundamental. It speaks directly to a massive area of technical debt on so many e-commerce and information sites.
It does. If you've got product details hidden under tabs or accordions, which are great for user experience. By the way, Googlebot will not execute a click command just to reveal what's inside.
So what's the core technical solution then? How do we make sure Googlebot can parse all that extra content, all those long-tail keywords buried in the product details, even if a user has to click to see it?
The information must be contained fully within the document object model, the DOM, on the very first load of the page. This is completely non-negotiable for indexation.
Okay, so it can be hidden from view for the user.
Exactly. You can style it with CSS, display, none, or something settler, but it must not be hidden in the underlying code. It can't require a JavaScript event, like a click, to actually inject the content into the DOM structure itself.
So we're really playing a balancing act. We're trying to maximize the user experience by tidying things up visually, but ensuring maximum crawlability by putting all the data in that initial server response.
Absolutely. You're giving a complete transcript of the page to the machine instantly, regardless of the visual design. We can use that analogy we talked about before.
The box and the key.
The box and the key. Think of your critical HTML content as being hidden in a box. JavaScript is the key the user has to turn to open it.
Okay.
If your page architecture means Googlebot has to use the key, meaning it has to execute JavaScript just to generate the content, you're creating instability. You're creating an indexation risk.
But if the content is already there in the initial DOM, the server has essentially opened the box for the bot ahead of time.
Precisely. The content is visible immediately. The technical nuance here is all about the browser's main thread. When a user clicks a tab, the JavaScript takes over the main thread to change the DOM.
Right.
If the content is only loaded during that event, the machine can't see it without simulating that event. But if the content is already in the DOM, that JS event might just be changing a CSS rule from display, none to display block.
Which is a much less demanding and more reliable operation.
Far more reliable. That static presence in the DOM is the ultimate safeguard.
This need for immediate full DOM access, it leads us right to the architectural solution that really fixes this for both Google and, as we'll see, the LLM bots.
Server-side rendering.
SSR.
This is maybe the single most important architectural decision you can make today. Server-side rendering, or SSR, is when the entire web page is rendered, built, and, constructed on the server itself.
Before it's ever sent to the client.
Right. Instead of sending a blank slate, the server prepares a complete, fully formed HTML file. It contains all the rendered content, the text, the links, even that hidden accordion text, and it sends that complete file to the browser or the bot.
So when Googlebot makes that first HTTP request, the very first thing it receives is the finished product, ready to read.
Exactly. The advantage for any bot is just enormous. The content, the HTML, it's all immediately accessible without waiting for any JavaScript to load, compile, or execute. The server did all the hard work already.
It created a static file with everything baked in.
Right. The interactive JavaScript can still be sent for the user's benefit, but the readable content is already there for the machine.
And this is where we see the big conflict with the popular trend of client-side rendering, or CSR. Why is CSR so popular with developers if it causes all these problems for bots?
Well, client-side rendering is popular because it's a much lower lift for the server. The server just sends this minimal, lightweight HTML skeleton.
Often just a single div tag with an ID.
Yeah, exactly. And a big JavaScript bundle. The server's load is tiny. All the heavy lifting, fetching data, compiling the JavaScript, building the page structure, injecting the content, all of that is offloaded to the client's browser.
Which sounds great for server scalability, in theory.
But for bots, it forces them right into Google's resource-intensive delayed rendering queue.
Yeah.
And for the LLMs, as we're about to see, it's often a complete death sentence for visibility.
It just creates this huge point of friction. The bot gets a skeleton, has to request the JS, download it, compile it, and then finally execute it to see what's actually on the page.
And that struggle is exactly why CSR sites suffer from slower indexation and, critically, why they just don't show up in the knowledge bases of these non-rendering AI bots.
So when you choose CSR for content delivery, you are.
Right.
You're implicitly accepting technical debt against your future AI visibility.
That's a perfect way to put it.
Okay, we have the high water mark. Googlebot is this highly sophisticated unified system that strives for complete rendering. Now, let's go to the new world. AI crawlers.
A different beast.
A completely different beast. These LLM bots, the ones powering ChatGPT, Perplexity, Claude, they force us to just discard years of our technical assumptions.
They are a chaotic, evolving ecosystem.
Yeah.
And the most important thing to realize is that there's no one governing body here.
Right.
These are not all the same. They're distinct, competing, proprietary systems. They often have different goals. Googlebot's goal is real-time search ranking. And LLM's goal is knowledge extraction.
To build an internal knowledge graph.
Exactly. And the underlying tech reflects that difference in purpose.
So what Claude's bots can do isn't necessarily what OpenAI's can do. And neither is guaranteed to match Google's.
Not at all.
So if there's no standard, what's the immediate strategic imperative for a technical team? What do?
You have to play defense. It has to be defense in depth. You strategically have to cater to the lowest capability bots.
To the lowest common denominator.
Exactly. If you only optimize for the most advanced system, say a Gemini bot that gets to piggyback on Google's existing infrastructure, you risk being completely invisible to, 80% of the independent LLM landscape.
So if you're relying on CSR, you're effectively choosing to be invisible to these new platforms that are answering more and more user queries directly.
You're limiting your own visibility by choice.
Okay, this brings us to the critical data. We know less about LLM bot rendering because, unlike Google, these AI companies aren't sharing detailed info.
No, there's a real lack of transparency, so we have to rely on testing on independent tests.
And what have those tests revealed about these multi-billion-dollar AI companies?
The findings are, well, they're sobering. Primarily from big investigations like the one Vercel did in 2024. They studied the JavaScript rendering of all the dominant independent LLM bots.
This OpenAI, Anthropic for Claude, Meta, ByteDance, Perplexity. The big names.
The big names. And the overwhelming consensus finding.
What was it?
The staggering conclusion was that none of those major independent bots were able to successfully render JavaScript.
None of them.
None. They were incapable of completing that full second wave indexing process that Googlebot handles. They basically stopped after the initial crawl. They only read the static HTML and the initial DOM.
That is a tectonic finding for the web. That means any core business content, product reviews, legal text, detailed specs, if it relies on client-side JS.
It was completely invisible to the foundation of these massive generative AI models.
Why? What's the technical reason for that gap?
It's all about priorities and resources. Running a full headless Chrome browser environment, which is what Googlebot does, is just exponentially costly. CPU, memory, time, it all adds up.
And LLMs are focused on something else.
They're focused on processing petabytes of text data as fast as possible to build knowledge graphs. They're optimized for speed and static text analysis. The cost-benefit analysis just doesn't favor the heavy, slow task of full JS rendering.
Right, their primary goal is knowledge extraction,
Mhm.
which works just fine on static HTML for the most part.
And we should mention the exceptions because they kind of prove the rule,
There were a few bots that were able to render.
a very small number,
Yeah.
and they all highlighted the massive infrastructure investment required. You had Gemini.
Which is using Googlebot's own rendering stack.
Exactly. Applebot. And Common Crawl's CCBot. The fact that the list of successful renderers is so short and includes the company that pioneered the tech, it tells you everything.
It is not a trivial engineering task.
Not at all. And for the independent players, it seems to be a cost they're just unwilling to bear. And that makes static HTML the only reliable target for them.
The implication for any organization is just crystal clear. If your key information requires JS execution to become visible, you are effectively opting out of the knowledge base that is defining the future of AI search.
And that inability with JavaScript is just compounded when we look at the interactively hidden content, the tabs and accordions.
Right. Googlebot could at least see the content if it was already in the DOM, even if it couldn't click. How do the LLM bots handle that?
If they struggle with general JS rendering, I think we can guess how they do with content that requires a specific JS event, like a click.
They must struggle even more.
The short answer is they fail routinely. If revealing that content requires any JavaScript execution to fetch it or build it, if it's not fully in the initial DOM, they will struggle profoundly.
They just can't process the JS, so they never even get to the point of needing to simulate the click.
Exactly. And this creates this critical intersection of technical debt. If you used a CSR framework to power your PABs 5 years ago, assuming Google would just figure it out.
You've now guaranteed that all that crucial information, all those long-tail keywords you hid in that accordion, are now completely invisible to Claude and Perplexity.
Absolutely. So that architectural solution we mandated for Googlebot, that the content must be in the DOM on the first load, it's now an absolute non-negotiable prerequisite for LLM bots.
This is a huge pivot in how we need to think about modern web architecture.
It is.
So the mandate is clear. For LLM visibility, you have to make sure the content loads fully in the DOM without requiring any JavaScript execution to create it.
Your human visitors can still use the JS for a slick modern experience, but the machine must see the complete information payload immediately from the server.
And this isn't just primary content, right? It's all the supplementary stuff too.
The really valuable stuff, user comments, product Q&A sections, dynamically updated pricing tables, regional info. If any of that is loaded client-side via JS function, the LLMs are just blowing right past that valuable high-relevance text.
So the goal is to move that content assembly work back to where it used to be, back at the server.
Back to the server.
Okay, we've dissected the challenge. Now we need the practical solutions, the actionable steps our listener can take today.
We need a clear, multi-layered checklist to debug this for both the highly capable Googlebot and the lower capability LLM
A
bots.
checklist. I like that.
So I think we need 4 specific checks. One for the generalized DOM, one specifically for Google, one for the LLMs, and then the ultimate guaranteed fail-safe check.
Let's start with the foundation. Inspecting the document object model, the DOM. Can you just remind everyone in simple terms what the DOM is and why it's so critical here?
The DOM is essentially the browser's live blueprint of your web page. It's an interface that represents the HTML page as a family tree of nodes and objects.
Every tag, every paragraph, every link is a node in that tree.
Exactly. When your browser reads the raw HTML, it builds this live interactive tree. And if your content is in that tree upon first load, the bot has a chance of seeing it, even if it's visually hidden.
So if the content is built into that tree before any user clicks, it satisfies the basic requirement. How do we check that with Chrome's developer tools?
We use the Elements tab, which shows the live DOM. So, step 1, go to the web page. Step 2, right-click anywhere and select Inspect.
Which opens up the developer tools panel.
Right. Step 3, you go immediately to the Elements tab. This shows you the current live DOM structure of the page as the browser sees it after the initial load.
And step 4 is the critical part.
The most critical part. You search for your specific content before you interact with the page in any way. Use the search function right there in the Elements panel and look for the text you think might be hidden.
So if I search for the text of an FAQ that's hidden inside an accordion, and I find it in the Elements tab before I've clicked to open that accordion,
Then you're passing the first test. If that critical content is fully within the DOM on that first static load, it means it should be visible to Googlebot after it renders. And just as importantly, it should be visible to the LLM bots that can at least read and parse a basic DOM structure.
okay, so that DOM check is a good general test. But if we want to be 100% certain that Googlebot specifically is happy,
Then we have to use Google Search Console. There's no substitute.
this is the definitive check for whether our client-side rendered content actually survived Google's rendering queue.
Exactly. You log into Search Console, you use the Inspect Any URL field at the top and paste in your URL.
And then you want to select Test Live URL.
That's vital because it forces Googlebot to try and render the current version of the page in real time. It bypasses any delays in the standard queue.
And then the final analysis, what are we looking for?
When the test finishes, you have to click View Tested Page. Go to the Screenshot tab to visually confirm what Googlebot saw, but more importantly, check the rendered HTML source.
And if the JS-dependent content is missing from that rendered HTML,
You have an immediate Googlebot indexing problem, and you need to move that content to SSR or static HTML delivery right away. This is the ultimate confirmation of success or failure for Google's rendering engine.
okay, now for the toughest one. The LLM bots, they don't have a Search Console equivalent, so how do we diagnose what they can see?
We have to get creative. We have to use a more experimental conversational method. You can actually prompt a public LLM like ChatGPT or Claude to read and summarize a specific web page for you.
You're essentially turning the LLM into a self-reporting trawler.
You are. And you need to be really specific with your prompt to force it to engage with the dynamic content.
So instead of just summarize this page,
Right. You just ask something like, read the URL, and you insert the URL and list the 3 main bullet points found under the Technical Specifications Accordion tab.
that forces it to try and parse the content inside a potentially problematic JS element.
It does. And if it fails, it will often tell you why.
Really? What does that feedback look like?
You'll get these frustrating but very helpful explanations. It might say it encountered difficulties accessing the content due to limitations with JavaScript execution on that page.
And that direct feedback is invaluable. It confirms your content is invisible to that specific AI knowledge base.
And that's all the evidence you need to shift to a server-side model.
Okay, we've covered the general, the Google specific, and the LLM specific. What's the last check? The ultimate fail-safe.
The fail-safe goes back to our strategic imperative, catering to the lowest capability bots. If we're dealing with systems that we know struggle with JavaScript,
Which is most of the independent LLMs.
then we need the ultimate, undeniable test. That fail-safe is the static source HTML.
This is the most important technical test for future AI visibility.
It is. We're prudently assuming that most LLMs cannot or will not reliably read content that requires any JavaScript execution.
So how do we confirm our content is in that basic static code before any script runs?
It's the simplest check of all, but it's the one that truly matters for LLM accessibility. In Chrome, you just right-click anywhere on the page and you select View Page Source.
And this is not the same as Inspect Element.
Not at all. View Page Source shows you the raw, basic HTML code that the server sends to the browser before any JavaScript has a chance to run.
So if you can use Control+F or Command+F and find your critical text inside that static code,
You know it's in the source HTML of the page. It's guaranteed to be available to all bots, including the lowest capability LLMs, regardless of their rendering limits.
it just bypasses the rendering stage entirely and speaks directly to the machine.
That's right.
So if we pull all of this together, what's the core difference here? It seems to boil down to economics and mission.
That's a great way to put it. Googlebot has this highly developed JavaScript handling because its mission is to build a complete real-time index of the live interactive web. That requires rendering.
But LLM bots are different.
Fundamentally different. Their mandate is rapid knowledge extraction for training models and for summarization. They're optimized for data processing speed, not for running resource-intensive virtual browsers.
So it's not really accurate to say that LLM bots are just behind Googlebot and that they'll eventually catch up.
No, I don't think so. They might never choose to mimic Googlebot's behavior because the economic cost of operating a full-scale headless browser for every single page they scrape, it just doesn't align with their function.
Which is extracting static text to build knowledge.
That is the critical insight. And that realization leads us right to the final balanced strategy, the comprehensive two-pronged approach that mitigates all this risk.
So prong one.
Prong one, to satisfy Googlebot and maintain high standards of indexation, you have to ensure all your pertinent information loads in the document object model on that first request. This covers the complexity of modern web design and ensures Google's rendering service can process it.
And prong two?
Prong two, to satisfy the LLM bots and all the other low-capability systems out there, you have to ensure your most critical content is accessible in the static HTML source.
So if you have core product descriptions, key facts, primary article text, it should be there when you click View Page Source.
Which often means shifting those content-critical elements from client-side rendering over to server-side rendering.
And doing that technical diligence, it insulates you against what seems to be the biggest risk in web development right now. Building up technical debt against AI visibility. And this brings us to that final provocative thought, which is referenced in the sources, the technical SEO debt that will destroy your AI visibility. When we look at these test results, seeing these huge multi-billion-dollar AI companies struggling with basic JS rendering, it forces you to think about the long-term impact of the choices you're making today.
It really does. If you rely heavily on client-side rendering for critical content right now, you're creating a form of technical debt. It's invisible to your traditional SEO reports, but it will make you irrelevant to the dominant information surfaces of tomorrow.
So that simple architectural decision, where's your content assembled? On the client's device or on your server, that is now a huge strategic decision.
It's a strategic decision about whether or not you even participate in the future of generative AI answers. And that is a choice that every developer and every SEO needs to be grappling with right now.
That was a crucial deep dive into the technical architecture, separating traditional indexing from this new era of generative AI. Thank you for joining us on the Deep Dive. Let us connect on LinkedIn or email us your queries at info@thedeepdive.com. That is deep with 3 E's.